Okay, so combining transformations, just a slight extension of what we did last year. I think we looked at some combinations of transformations last year, but also we've done this in at GCSE. Right, make a note of the heading. When you're ready, hit play again and we move on. So the transformations from last year, these include f of x plus a. So the transformation or the translation is within the function. So it's minus in the x direction. Okay, remember it's counterintuitive. When the translation is outside the function, it's in the y direction, it stays positive. F of minus x reflects the function in the y-axis. When we've got the negative outside the function, reflects it in the x-axis. When you multiply by a factor, this is a vertical stretch, so it affects the y value. And when you put the factor within the function, it's a horizontal stretch. And again, counterintuitive, instead of multiplying it, it's 1 over that factor. Good, make some notes of those as a reminder and hit pause, and when you're ready we'll look at an example. So in this example they want us to, they've sketched us y equals the function of x, it's a cubic curve, and they want you to sketch a graph of 2 of f of x minus 1. So where we have 2 of f of x, what we're doing is we are doubling the y coordinate. So where we've got minus 1 here, we're going to have it times 2. So it'll be minus 1 times 2, gives us minus 2. But we're also subtracting 1, so it'll be minus 2 minus 1 gives us minus 3. Here the y coordinate is 4, so we double it first, that gives us 8, but we subtract 1, so that takes us to 7. Okay, so double the y coordinate and increase it by 1, decrease it by 1. Double that, minus 1, double that, double 4, minus 1 gives us 7. And we can now sketch it. And where it crosses the x-axis, you notice it's gone down by 1. So where it crosses the axis, it's gone down by 1. Where it crosses the axis there, it's gone down by 1. Good. Hit pause, sketch the curves, and we'll look at another example. When you're ready, hit play. So with this translation, this example, sketch the graph of y equals f of x plus 2 in brackets plus 2. So we do what's in the brackets first. The translation f of x add 2 is a shift then to the left. Because it's plus 2, it's a shift along the x-axis 2 times. So instead of 2 here, that's going to go to 0. And instead of 6 here, that's going to go to 4. Okay. And the same thing where it crosses the x-axis. So it's a shift to the left, but also we've got to add 2, so it shifts upwards as well. So it shifts to the left first, 2, and up 2. So instead of 2, that goes 0, and instead of minus 1, that goes to plus 1. So 0, 1, and that shifts across 2. So instead of 6, that's 4. And instead of 4 goes up 2, so it becomes 4, 6. And we can now sketch our curve like so. So again, hit pause, make some notes. When you're ready, hit play again. On this example then, we're going to sketch the graph of a quarter of the function 2 of x. So this time, we look at 2 of x. Remember, it's counterintuitive when it's within the brackets. So instead of doubling the x value, we halve the x value. So instead of 2, that becomes 1. And instead of 6, that becomes 3. And it's a quarter of the y value then. So instead of minus 1, it'd be minus a quarter. And instead of 4, becomes 1. So our coordinates will be 1 minus a quarter. And here instead of 6 we have 3, and instead of 4 we got 1, so 3, 1. There you go. So now you can sketch this smaller version of the curve. Good. Make some notes. So hit pause, make some notes when you're ready. Hit play again. This time we need to sketch a graph of y equals minus f of x minus 1. X minus 1 means a shift to the right in the x direction, and then minus f of x means that we're going to reflect the curve then. So we shift it to the right first one, and then we reflect it in the x-axis, So we shift it 1, so that becomes 3 minus 1, but then we reflect it. So instead of 3 minus 1, it becomes 3 plus 1. And here, instead of 6, it becomes 7, 4, and we reflect it down to 7 minus 4. And then we can sketch the reflection like so. Again, hit pause, make some notes. When you're ready, hit play again. So, got this example. And if the function is log of x, and what we've got to do is sketch the graphs of y equals 2 times f of x minus 3. So that's our sketch of y equals ln x. If we double ln x, we double all the y values, so we stretch it out in the y direction, so it becomes more stretched in the y direction. Still tends towards the y-axis, where x equals 0, never actually getting there. And then minus 3 means that we shift it down 3. So it should look, so it's asymptotic on x equals 0, which is the y-axis. Doesn't actually get there. And when we stretch the curve then, we are doubling all the y values, so it's stretched out, but we also then shift it down 3. So we shift it down 3. Right. So here we want to, we've drawn our curve, but we can find out where exactly it crosses the x-axis by setting y equals to 0. Now our function we've been given was y is equal to 2 of f of x minus 3, which is 2 times log of x minus 3. If we set y equal to 0, that means we've got 2 log of x minus 3 equals 0. So log of x, or 2 log of x, is equal to 3. Log of x then, put this in brackets, is equal to 3 divided by 2, or 3 over 2. And so x then is going to be equal to the exponential value of 3 over 2. And you can work that on your calculator for me. We should be getting 4.48. So the x value here, 4.48. Good. Let's have a look at part B of the question. Y equals the modulus of f of minus x. Hit pause, make some notes. When you're ready, hit play again. So for part B, we want to sketch y equals the modulus of f of minus x. When it's minus x, that means it's going to be a reflection in the y-axis. So it's going to look like that. If we sketch it, like so, so that's what log of minus x looks like. It's a reflection then of log of x in the y-axis. But we've got to find the modulus of it, modulus of the function, which means that it can never be negative. So for whatever value of x we've got, the function stays positive. So we're going to have to reflect it from here. Okay, so it can never be negative, so we've got a reflection there like that, and then we Remember, we erase everything below the x-axis. And there you go. So that's your y equals the modulus of log of minus x. Make some notes and then you can attempt some questions for me. So your exercise is exercise 2F. And off you go. I was going to say stick to the left hand side of the page, but on question 1 and question 2, it's quite, they're all very different transformations, so it's good if you attempt them all. Okay. They're not many questions, you only got 5 questions. Good.